Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Today we learn about the Coordination Chemistry Lecture 4, Nomenclature of Coordination Compounds. In the last lecture we have studied about the IUPAC nomenclature of some compounds, and in that we have seen in anionic complexes, in cationic complexes, or in the neutral molecules, how we can give the names. There are some other examples, or in that we give the names when there is certain changes in that simple compound. And so naming of prefixes in the nomenclature is also one of the important point. So there are some ligands, and that ligands contains the word di, tri, tetra. Already it is present, and when such type of ligands, when we use in the coordinate complexes, and again such ligands are in the 2, 3 or 4 numbers, then by addition of the di, tri, there is repetition of the di, tri, and there is problem that what is the actual name of that, or there is sometimes confusion in the name. And for that purpose, instead of using di, tri, tetra prefixes, here we use some other prefixes, and in that for the di we use the prefix bis. For tri, prefix use is tris, and for tetra, prefixes use is tetrakis. And when these prefixes are used, then there is not confusion in the name. And so such type of prefixes are used only in cases when already in that ligand there is word di, tri or tetra or such type of words. For that purpose, we take some examples, and from that you get idea about how we use the prefixes. So here we take the example COEN2, Cl2, bracket complete, and outside the bracket Cl. So here En means ethylene diamine. So in that name ethylene diamine, there is word di, ethylene diamine, and such type of two ethylene diamines are present. And when we use that diethylene diamine, then there is repetitions of di and there is confusion. And to avoid that, in this case, instead of using di, we use here bis. Other rules are same. So here chloro is negatively charged ligand, En is here neutral ligand. So firstly we use here chloro. So there are two chloro ligands, so we use dichloro. Then two ethylene diamine, so we use the bis instead of the di. So bis, after that we use dash. Then ethylene diamine is one ligand, so it is written in the small bracket. So after that, name of the metal is written, its oxidation number is written in parentheses. So this all is written in the one word, that is the similar rules that we already discussed in the last lecture. And so again we repeat this name, dichloro bis ethylene diamine cobalt 3 and chloride. So this is the name, and this name is similar to the other rules, only difference that we use the prefix instead of di bis in case of the ethylene diamine. So like that we can use such type of prefixes in case of the other ligands, and we use its names very simply. Then we see the oxidation number, how we can give the oxidation number. So already in the different examples, we have used the oxidation numbers, that is the +3, +4, +2. But in some cases, that oxidation number may be 0. In some examples, oxidation number is minus. So in some examples, oxidation number of metal is minus. And so that minus oxidation number also we can show, because generally we say that oxidation number of metal is generally positive, and how it is minus. But when it is minus, then we write the such type of oxidation numbers minus, 0 or plus in the parenthesis or in the small bracket. And so such type of examples we take here, and from that you get idea how we can give the oxidation number. So here we take example of NaCO, CO4. So here CO means carbonyl ligand is present and cobalt metal is present, that is in the square bracket, and outside the square bracket there is sodium. So this is the anionic complex ion, and in anionic complex ion, here outside the bracket there is sodium, which is used for the balancing the charge. Now we use the same rules. So firstly we find the oxidation number of cobalt. So outside the bracket there is sodium. So on the square bracket there is -1 charge. Here carbonyl has neutral ligand, so that cobalt carries -1 charge. So in this example, cobalt metal carries -1 charge, and so we write that in this small bracket. Now we give the name sodium tetracarbonyl cobaltate. So end of the metal is by ATE. So already we have seen in the first rule that in anionic complexes, name of the metal is ended by ATE. So here cobaltate name, and in the bracket -1. So again we repeat this: sodium tetracarbonyl cobaltate -1. This is name for this first compound. Now second compound, K4NiCN4. So in this complex K4NiCN4, 4 CN is attached with nickel, and outside the bracket there is K4. So when there is K4, then that square bracket carries -4 charge. Now you see here in the CN there is -1 charge, and such type of 4 CN is present. So charge on the nickel is 0. Means in this example nickel has 0 oxidation number, and accordingly we give the names. Now again rule is same. Firstly we write name of cation, that is potassium, then tetracyanonickelate 0. So here nickel is present in the anionic complex ion, and so its end is done by the ATE, and so name is potassium tetracyanonickelate 0. This is the name. And so you remember that when there is any coordinate complex, then its oxidation number is written in the small bracket or parenthesis, and that actual oxidation number of that metal is written, that may be neutral, minus or positive. Then one of the other point, that point of attachment. So in certain ligands, if there is unidentate ligands, and that unidentate ligand itself contains 2 or more than 2 donor atoms, then out of that donor atom only one is donated at a time, or only one is donated to the metal at a time. So in that case, which metal donated, that is shown by point of attachment to the metal. So when we show this point of attachment, then at that time we write the name of that ligand, and that is shown connected with that metal, and that is shown by the dot. For that purpose, we take simple example NH3 thrice CrSCN. So in the square bracket there is CrSCN, and SCN means that is thiocyanate. Already we have seen that is the different names of the ligands. So SCN means if sulfur is donor atom to the chromium, then that is called as thiocyanate. And that thiocyanate connected with the metal through sulfur, so we write thiocyanate S chromate. Now other rules are similar. So outside the square bracket there is NH3 plus. So NH3 is molecule, and there is 3 molecules, and CrHCN6 is present. So we write the name ammonium. So here one printing mistake. Here there should be, instead of the NH3, NH4. So we write here instead of this NH3 there is NH4, and that NH4 thrice is present. So NH4 thrice CrHCN. So that is the ammonium ion which is positively charged, and this is the anionic complex ion. So its metal name is end by AT. So we write the name ammonium hexathiocyanato S chromate plus 3. So this is the name of this complex, and in this example we show the point of attachment, that which donor atom is attached with metal. So here metal is chromium, and to that chromium sulfur is attached. So we write the cyanato S chromate. So this is the name. In some examples, the ligand name is very long and they are complicated. So when such type of ligand names are written in the name or in the nomenclature, then that nomenclature becomes very long. Name becomes very long. So in that cases, some short forms are used, and that short forms are called as abbreviations. For example, ethylene diamine. So this ethylene diamine is one of the ligand. This is very long name. So to avoid this long name, we can write its abbreviation EN. Then 2,2-dipyridyl. That 2,2-dipyridyl, it is simply written as dipy. Then glycinato, it is written in the abbreviation form GLY. Then dimethyl glyxamato, this is also very long ligand name, but shortly it is written as DMG. Oxalato is one of the ligand. That oxalato is written shortly as OX. So when we write only OX, then anyone can identify, anyone can understand that is the oxalato. Then ethylene diamine tetraacetate. So you see, this is a very long name, but instead of that we write the short form, that is EDT. In this way, such type of short forms we use in the nomenclature, and we can identify that very easily. In some examples, that ligands are present to the metal through bridge. You see this example FeOH Fe. There is metal Fe, and hydroxo group is attached. Hydroxo ligand is attached. But that hydroxo ligand is attached not only in one metal, but it is attached to the two metal. And such type of ligand, that is called as bridge ligand. And when such bridge ligand is present in the coordinate complexes, then which ligand is attached by bridge, that is shown by the certain symbol, and that symbol is called as mu. So that mu denotes there is bridge ligand. And so its nomenclature is similar, but only we can show that which are the bridge ligand, and that mu is added in the nomenclature. In this example, two hydroxyl groups are present, and that is negatively charged. 8 aquo ligands are present, and these are neutral. In this case, when there is bridge ligand, then in that case we can change the sequence. Instead of the negative ligand, we can write the neutral ligand firstly, because here negative ligands are attached with metal, and so they are shown with attachment to the metal, so they are shown close to the metal. So firstly we write the aquo ligand, that is 8 aquo ligands present, so we write octa aquo. Then we write hydroxyl ligand. There are two hydroxyl ligands, so we write dihydroxy, and that 2 hydroxy is attached by bridge, so we write mu dash dihydroxy di iron 3 and sulfate. So this is the name for this bridge ligand, and so you remember that when there is bridge ligands, then we can use the letter mu before that bridge ligands and give the names. All other rules are similar rules, or we can change the sequence of ligand in this case. Then if there is certain geometrical isomerism, then in that geometrical isomerism we give the B.Sc nomenclature. So geometrical isomerisms are named by the terms cis and trans. So we see what is by cis and what is by trans. So cis means the ligands which is at the adjacent position, means which is at the 90-degree with each other. That is called as cis, or that is also called as simply same, means ligands are present at the same side, at the one side, then that is called as cis. And trans means same type of ligands are at the opposite side or in the 180-degree angle away from each other. That is called as trans. So such type of cis and trans positions we can show in the geometrical isomerism. In addition, it is essential to use a number system to show the position of each ligand. Means in some cases all the 4 ligands are different, or 3 ligands are different. In that cases we not show the cis and trans phenomenon. In that case we can use the positions, means which ligands are attached at position number 1, 2, 3 or any other, and accordingly we can write the position before the name of that ligand. So this one system is also used. So we take one example, from that you get idea. So you see, this is the common, this is the square, and in that metal is present at the center and 4 ligands are attached at the 4 positions of that square. In that case we give the number 1 to any one of the ligands, and other numbers, that is 2, 3, 4, they are given sequentially to the other ligand. So if we give here one number 1, then we give the number 2, 3, 4. Or there is also we use in this way number 1, 2, 3, 4. Or if we give number here 1, then we can also give 2, 3, 4. In this way only we take care that we give the number 1, and after that other numbers are given sequentially in the clockwise direction or in the anti-clockwise direction in any positions. Now we take here one example. Here platinum is the metal, and to that platinum one Cl is attached, one NH3 is attached, other NH3 is attached, and third ligand is NO2. Means in this example 3 types of ligands are present. One is NO2, 2 NH3 and 1 Cl. Now if we see here, then here Cl and NO2, these are the different ligands, and these are the at opposite position to each other. So this is the trans isomer. And so before writing the name of that ligand, we write the trans before that. If there is same position or cis position, then we write the cis. No, so this is the trans position, so we write trans. Other name is similar, that we write the chloro, nitro, diamine, platinum plus 2. Means in that there is one chloro ligand, one nitro ligand, and two amines are present. So in that first we write the negatively charged. In that negatively charged, one is chloro, other is nitro. So alphabetically first is chloro, so we write chloro, nitro, then diamine, platinum plus 2. This is the example. Now we see here other example, that in that example platinum is the metal and four ligands are different ligand, that one chloro, one bromo, then one is nitro, and one fourth is amine ligand. So here cis and trans concept we not use because all the four ligands are different. So in this case we can use the numbering. So in that generally we give the number 1 to the ligand which have negatively charged, and alphabetically they have numbers. So here if we consider this is the number 1, this is 2, 3, 4, then in that case we use here that at number 1 there is chloro. So 1 chloro, 3 nitro, bromo, amine, platinum, 2 iron. Because here on the complex there is plus charge, and so we write the iron. So in this way we can use the geometrical isomerism names when there is cis and trans concept or there is numbering. Again we take one example of octahedral complex. In octahedral complex, here metal is present at the center, four ligands are present at four corners of the square, and two are at the axial position. So in that, how we can give the numbering? So if two ligands are same and other four ligands are different, in that case generally the number 1 ligand is given at the top side ligand. Then number 2 ligand is given to the position, one of the position is square, and other positions sequentially given the numbers. So if number 1 is given to this top one, then number 2 is given to this, then 3, 4, 5, and last number 6 is given to the bottom side ligand. So remember that number 1 is top side, number 1 is bottom side, and other number 2, 3, 4, 5 are in the square or at the four positions of square. And accordingly, we can write the cis and trans concept. If position number 1 and 2 contains same type of ligands, then such positions are called as cis positions. And if position number 1 and 6 contains same type of ligand, then that position that is called as trans positions. And accordingly, we give the names. Sometimes position number 1, 2, 3 contains same type of ligand, and 4, 5, 6 contains different type of ligand, then that is also called as cis. Now we take one example, and from that you get idea how we can give the names of that coordinate complex. So here we take the example PT NH35 NH34 Br2. In this case, Br is present at position number 2 and position number 3. NH3 is present at position number 1 and 6. So position number 1 and 6 is occupied by the NH3, same type of ligand. So this is the cis structure. And so when we give the names, then we write before that name cis, then write dash. And again, name is written as same, that is negatively charged ligand first, neutral ligand, after that positive ligand, and name of metal, and its oxidation number is small bracket. Now here two bromo ligands present, so cis dibromo tetraamine, then platinum plus 3 ion.